X squared plus 3x equals 2. Yeah.
Okay, so we're completing the square. And they like normally, let me back up, because normally it would be written like this, and then I would tell you to move the 2 over. The difference is that I'm leaving a space.
Okay.
Leave a space, and that's critical because that space gets filled in on both of these. So in this most simplistic basic form where there's a 1 out in front, that's a huge caveat here, but it looks like it works for this one. You take half of this number, which is 3 halves, and then you square it. So you half, and then you square it, and that's what goes into this space here.
Okay.
So that ends up being 9 over 4. 9 over 4. Okay. That should have been explained in class or in notes or something, but it is a formula. Now what goes down here is half of that. So it's just the half part, not the square part. So it becomes x plus 3 halves, and then you put a 2 there.
Yeah.
So the idea is that if you were to expand this, x plus 3 halves squared, if you were to write x plus 3 halves times x plus 3 halves, you would get back to x squared plus 3x plus 9 over 4.
Mm-hmm.
Okay, now on the right side, you have to combine these. It's 2 plus 9 over 4. 2 over 1, you immediately say to yourself, okay, that's 8 over 4. So this is 8 over 4 plus 9 over 4. It's 17 over 4. It's very common that the bottom is something that you can take the square root of.
Yeah.
Because that is the next step here. You have to take the square root of both sides. So it's the square root of x plus 3 halves squared equals plus or minus the square root of 17 over 4. The left side, go ahead. Oh, maybe you didn't interrupt me. On the right-hand side here, it's the square root of 17 over the square root of 4, which becomes plus or minus the square root of 17 over 2. When you subtract 3 halves from both sides, you get 2 answers here. You get square root 17 over 2 positive minus 3 halves, comma, negative square root of 17 over 2 minus 3 halves. And it's solved. You're done here. Any follow-up to that? Ella, you still with me? Oh no. Checking. You're still here. I'm just going to send you a message because I just don't want to make sure you don't be missing out on something. You're not there. Okay. You'll be back in the room.
Okay.
Hey, Ella.
Yeah, sorry. I got kicked out or something.
If the problem persists, one thing I could do, since you're just trying to get through these problems, is I can continue the video and give you the explanations for them.
Okay.
Do you think it? I mean, do you think you've got a stable enough connection that we can continue?
Yeah, it seems to be fine now.
Okay.
I'm not sure what happened.
Okay. So 68. It's the same set of instructions. It says 5x squared minus x equals 4. Excuse me. Um, the way I suggested doing this is you leave a space here and you fill that in. Now the the whole like take it cut this number in half in front of x for completing the square, that only works if there's a 1 here in front. There's not a 1 here in front. So what you could do is you could divide everything by 5. Maybe that's what you saw in class. I don't really know. Um, but I'm going to go for that here. So we're actually going to take this and divide everything by 5. So you get x squared minus 1/5 x, leave a space, equals 4/5.
Okay.
So now it looks like what you had before. You can take a half of this number. You can cut that number in half and then square it. Now that doesn't look great, but that is allowed. That is totally allowed. Like 1/5 divided by 2 is 1/10. 1/10 squared is 1 over 100. So this becomes 1 over 100. 1 over 100.
Okay.
Down here, it's half of this number minus 1/5. Well, we already know half of it is 1/10. It's negative because of that, and then you square it. On the right here, you have to make a common denominator. The common denominator is going to be 100. So this is 80 over 100 plus 1 over 100. So you get x minus 1 over 10 squared equals 81 over 100. You're going to take the square root of both sides. Now, so the square root of both sides gives you the reduction down to x minus 1/10 equals plus or minus square root of 81 over square root of 100, which is 9 over 10. So this becomes x minus 1 over 10 equals plus or minus 9 over 10. So that when we add this to both sides, we get 1/10 plus or minus 9 over 10. There's two answers. There's x equals 1/10 plus 9 over 10, 1/10 minus 9 over 10. So the first one is 10 over 10, which equals 1. The second one is minus 8 over 10, which equals minus 4/5. So you get two solutions, 1 comma minus 4/5. This one actually factors nicely, but they make you complete the square to do it.
Yeah.
Any issues on that? Concerns on
No,
that?
I think I got
Okay.
it.
I mean, it's not that easy to do, but it's there is sort of a recipe to do it.
Yeah.
All right, so we're going to go back to number 20 on page 244.
Okay.
That's in the other file, so I'm going to just pull that second file up. Okay, so come on, load. Okay, number 20 is to solve each equation using the quadratic formula. This one is, I'm gonna post it here. Okay, this one, is this correct?
Yeah.
Okay, so we're solve using the quadratic formula. Okay, this is currently not in the right form. Like we expect it to be an ax squared plus bx plus c equals 0. That means you got to distribute and then move this over. So when we distribute, you get 2x squared minus 2x equals 3. And then you're going to move this 3 over. So it's 2x squared minus 2x minus 3 equals 0. I know this isn't your first time doing quadratic formula, but I'll just remind you that it's nice to label A, B, and C.
Okay.
Because the formula is about your ability to put these numbers into the formula. So if you know the values of A, B, and C, it's pretty straightforward to do that. Okay, so I'll also opposite of B. So we got 2 plus or minus the square root of. Whenever I have negatives and I substitute them in, I tend to put them in parentheses, minus 4 times 2 times negative 3, all over 2 times 2. Okay, we're going to work on the inside part of the square root. Again, it's 2 plus or minus square root of, this is 4, these two, this negative, and this negative makes a positive, so it's 8, 24 plus 24, all over 4. So again, a lot of writing, a lot of rewriting too. It's square root of 28 over 4. Square root of 28 reduces to 2 square root 7. So it's 2 plus or minus 2 square root 7 all over 4. You divide each of these by 4, so it's 2 over 4 plus or minus 2 square root 7 over 4 reduces to 1/2 plus or minus square root of 7 over 4. That's your final answer on that one. Okay, so 46, I got to jump back to the other PDF that you sent. It says rewrite each equation in vertex form. Okay, does that look right for you?
Yeah.
Great. So that's another way of saying complete the square. Okay, so it really, this problem is saying complete the square. It doesn't say to solve it. When you, by completing the square, it ends up going into vertex form. So let's do it that way. So look at this part right here.
Okay.
Set it equal to 0. And then move the negative 1 over. So it's x squared plus 4x equals negative 1, because you subtract 1. So do you remember how we figure out what number goes in these positions right here?
It's half of 4 squared.
Exactly. What does that become?
4.
4. So it just so happens to be the same number both times. This, I call this the compressing step here, because you're turning 3 terms into 2. It's x, and then it's half of this, which is plus 2 squared, equals 3. Now this is the difference here. If we were solving, we would take a square root of both sides, but we're just rewriting. So since we're just rewriting, we're going to move the 3 over. So this becomes x plus 2 squared minus 3 equals 0. And this y right here, it's just going to come down. So it becomes y equals that. We got y equals x plus 2 squared minus 3.
Okay.
Is it okay to move on, or is there anything else to clarify on this?
Yeah, we can move on.
So everything else was on that original one that you sent. I do have to scroll up here to find the problems we're looking at. So 253, 30, 38, and 44. 30 is completing the square. Okay. This one could have been done like first. Like it's sort of shocking that this wasn't like the first one to do, because there are questions that literally ask you like, what number do you need to complete the square, which is what this one is asking. It's saying like figure out what goes here, here, question mark. And you already know it's half of this, and then you square it.
Yeah.
Okay, so what's half of negative 24? Well, you divide it by 2, and then you square it. It's better to divide first, so you end up getting negative 12. Negative 12 squared is 144. That's it. I mean, I don't know. There's not much more to that. 38 is the next one, I think you said.
Yeah.
Okay. This one is more involved. I mean, this is more of that traditional completing the square stuff. It's a skill that if you take more math, like meaning beyond high school, like if you go into college and you want to take calculus, you will need this skill again. I'm not going to sit here and say you need it otherwise, because you really don't. Help me out here. Tell me what goes in those positions.
So it's 16.
Agreed. Both places 16. Tell me what goes in parentheses here on the left.
Is it x plus 4 squared?
Yeah, the square's on the outside. It's always half of this.
Okay.
And then when you square it, like the squared comes up there, if that makes any sense, equals 17. This one says to solve it. Yeah, it does. So we have to solve. So we're not done.
Oh wait, it's 27, not 17.
Thank you. Yeah. So we have to solve this by what is the property that we use now to solve this?
I'm not sure.
Square root property.
Oh, okay.
So the square root here is plus or minus the square root of 27. On the left side, it's x plus 4. And on the right side here, it's becomes 3 root 3. So when you subtract 4 from both sides, it becomes minus 4 plus or minus 3 square root 3. It's usually good to put the number in front here and keep in front, just for clarity of the way this looks.
Yeah. Okay.
There was one more on that page. Which one was it?
Let me check.
I'll scroll up here. It's just, I should have wrote it down. 44.
Okay.
Okay, so 44. 44 is not great because it's got a number other than 1 out in front. These problems are significantly easier if it's just a 1 out in front. This one doesn't happen to be that case. So I mentioned before, you can just divide everything by it. I used to teach this another way. It's probably good enough to go like this, and then you want to move this number off to the side, the negative 2/9, and I'm going to reduce this fraction, so it becomes x squared minus 4/3 x equals 2/9. So this is where I know as a student you're a little uncomfortable, because it's like, okay, I got to take half of negative 4/3. which means dividing it by 2. Wow, this is my internet connection's unstable. And then squaring it. You're basically multiplying. Another way of dividing by 2 is the same as saying multiplying by 1/2 and then squaring it. So the result, whichever way you do it, it reduces to -2/3 squared. And that ends up being 4/9.
Okay.
So this is -4/6 squared, which is -2/3 squared. So that's being the same thing. So that 4/9 goes here and here. And sometimes students are like, they forget. They say, well, I don't know what to put here. Well, you already have it. It's the reduced thing, because that's what the half is. That's what goes here. It's also half of this -4/3. It's the same thing. It's whatever it reduces to there goes inside there. So it's exactly the same. The right-hand side is the 2/9 plus the 4/9. Okay, what does the right side reduce to?
2/3.
Now you might think to do that, but when you take the square root here, it's better if you leave it as 6/9, because you can actually take the square root of the bottom.
Oh, okay.
So that's kind of a tip, trick, whatever, to like do this more efficiently. The left side becomes x minus 2/3, but the right side becomes plus or minus the square root of 6/3, because that square root of 9 becomes 3. Then you can add the 2/3 to both sides. My recommendation is to put it in front, plus or minus square root of 6/3.
Okay.
All right, so we're done. We're done with that grouping of questions. We're on to the last page, 15 and 28.
Yeah, that should be like the 4th page I sent you.
Yeah.
It's solving by
Solve each system by graphing, solve by substitution. So the first one you have here is to solve by substitution.
okay.
Okay, so it does say to solve by substitution. Both are already solved for y. So you might think to put this in for that y there, or take this and put it in for that y there. You're basically setting the equations equal. And just for review here, the first one is a parabola. I have no idea what it does, but it opens down. The other one is a line. They probably hit 2 times.
Yeah.
It's also possible that they don't hit at all.
Mm-hmm.
And it's also possible that they hit 1 time. They just tangentially touch like that. We actually don't know yet. But we're going to set them equal. X plus 4 equals minus x squared plus 2x plus 10. It's best to get everything on one side of the equation. I'm going to go left because I really want positives. So here I'm subtracting 2x. So I got to subtract that 2x. That gives me negative x. Here I'm subtracting 10. That gives me minus 6. Can you factor this for me, please?
Yeah. So it would be 2 and -3 as so x plus 2, x minus 3.
Perfect. All right, so now what are the two x values here? This becomes -2 and 3.
Yeah.
And then what you want to do is use each of these to find the y value. So it's like, if x equals -2, what does y equal? You have two equations from the beginning. You have the -x² plus 2x plus 10. You also have the x plus 4. You probably should use that one because it's much simpler. -2 plus 4 is 2. So what your final answer is an ordered pair, -2, 2. And that's where those come from. If x equals 3, that's the second one we found. We still know that y equals x plus 4. You're going to put 3 in. So 3 plus 4, that equals 7. So you got 3 comma 7 as your ordered pair solutions.
Okay.
Okay, the next one, all those numbers, I actually don't remember what the other problem is, so I'll have to scroll up to get it. So let's see, 28. 28. And it's a solve each system by graphing. All right, I might need you to confirm the values here. Looks to me, I think this is readable enough.
It's
First,
y is less than -x² minus 3x.
yeah, so here's what I'm going to do. I'm going to switch over to Desmos.
Okay.
We're going to use technology. No reason not to at this point. Let me just get it on the right screen. Okay, boom. All right. So if you can see my screen,
Yeah.
I'm gonna graph it exactly as is, and then I'm gonna make the comment I usually make, which is that it's not necessarily very helpful to have it in this form, although it could be. Depending on the problem here, you're looking for the overlap. The overlap.
Mm-hmm.
So I think you can see where the overlap is
Yeah.
in this case. So I'm going to snip this and put it in, but I want to just show you the other approach that works really well in tests, and it's something I would definitely do if I were a student, to at least visually see how it could maybe be easier to view. So the approach is, instead of graphing it the way you see there, you graph the flip of it. Okay. And then I grab the other one and I graph the flip of it, meaning you switch the inequality. And this time you're looking for the white space.
Yeah.
So do you, I mean, you visually, I think you can see the difference.
Mm-hmm.
When you get 3 or more equations, it's usually better to do this second approach. When you
Yeah.
have one equation, I don't know, it's probably, or 2 equations, it's probably better to just look for the overlap. But you know, it's up to you. Here you're looking for the white space. Maybe your instructor wants you to put some words around this. I don't know exactly what they want, but it's the region between the two. It's the region between the two parabolas.
Mm-hmm.
So sometimes you know, it's the region between them. Sometimes you have to say, you know, above slash below, like above this one that opens up, below the one that opens down. I'm not seeing anything in your book that explains how they want the answer. It says see problem 4, so maybe that's somewhere you could look to get some clarity
Okay.
on that. All right, we're through all the questions that you asked. Where should we go from here?
I have another, just like a factoring practice that's due tomorrow. We could do
Okay.
that.
All right. Yeah, send it over. We'll start
Okay.
on that.
Okay, I just sent it.
Okay, I will check here. You said factoring practice, and that could mean a lot of things. Let's see what it is that you've got for us to. Okay. Yeah, this thing is about as old as I am. I remember getting stuff like this in Algebra 2, whatever, Algebra 1, pre-calculus, whatever, long time ago. Solve the equation or problem by factoring. Okay. Do you want to go through all of these, certain ones that look different?
I just have to do the odd numbered ones.
Okay. That is good enough. So I'm gonna just write them out rather than snipping.
Okay.
In all of these, you want to get everything on one side of the equation.
Yeah.
So this is going to be u squared plus 19u plus 60 equals 0. And this is the type where a equals 1. So you're looking for two numbers to multiply to 60 but add up to 19. U plus 15, u plus 4 equals 0. You're solving it though, so you have to set each of these equal to 0. U plus 15 equals 0. U plus 4 equals 0. So you get u equals minus 15 and u equals minus 4.
Okay.
So you'll find that down there. Number 3, 7x squared minus 10x equals 6x squared minus 21. Again, move everything to one side. And most of the time it's left, but what you're looking for is a positive x squared. So I want you to move everything left and tell me what you have as a result of doing that, please.
Okay. I have x squared minus 10x plus 21 equals 0.
Great. And now you're trying to find two numbers that multiply to 21 but add up to negative 10.
-7 and -3.
You set each of those equal to 0 and you get the results for that. Number 5, n times n plus 3 equals 70. If you remember the words, move everything to one side, you may have to do some distributing, you may have to combine like terms, you may have to even FOIL, but you have to get everything on one side.
Yeah.
This is n squared plus 3n minus 70 equals 0. If you're not comfortable factoring the numbers, like finding multipliers to get up to a number, use a calculator. No big deal on that, but this is n equals 7, n equals minus 10.
Okay.
7 is w plus 5, w plus 2 equals 40. This is an example of one where you have to FOIL the left side and then move the 40 over. So go ahead and do that and let me know when you're done with that, please.
Okay. Okay, so on the left side, it's w squared plus 7w plus 10.
Okay, and then if you move the 40 over?
So it's minus 30.
Okay, so tell me what this factors into and take as much time as you need to figure that out.
Okay. 10 and -3.
Perfect, so w equals negative 10, w equals 3. All right, we're on to 9. 9 looks pretty complicated. It's got a lot going on, but it's no different than the previous ones. You have to do whatever steps are needed, which in this case is to FOIL the left side and then move these over to get everything on one side of the equation. So go ahead and try that. Go ahead and FOIL the left side. Let me get FOIL the left side and then move the 3k squared over and the 11k squared over.
Okay. Okay, on the left side, I have 4k squared plus 26k plus 36.
Equals 3k squared plus 11k. So move everything left, subtract that 3k squared, subtract that 11k.
So it's, yeah, okay.
Okay. Two numbers that multiply to 36 but add up to 15.
Oh, yeah.
$11 could be considered an exception to what we're doing because it's already isolated something squared. You would take the square root of both sides. The way they want you to do this, though, let me write out the way they want you to do it is this, and then they want you to FOIL.
Oh.
And then they want you to subtract the 64, so you get m squared minus 6m minus 55 equals 0. And then you get m, let's see, minus 11 m plus 5 equals 0. Now, if you just went over here and you took the square root of both sides, you get m minus 3 equals plus or minus the square root of 64. M minus 3 equals plus or minus 8. M equals 3 plus or minus 8. M equals 3 plus 8. 3 minus 8. You end up getting the same thing.
Yeah, but they want us to do by fact.
They want this on the left, but you're welcome to do what's on the right. You know, is if you know in certain situations it's okay to take the shortcut for this.
Yeah.
$13 says a square banner had 4 feet added to its width and 2 feet subtracted from its height. This is kind of, I mean, so there, it was X and X, but then one had 4 added to it, another had 2 subtracted from it.
Okay.
And they know that the area is 91. So the idea is that if you find the product of these, it's supposed to equal 91, and you can solve it by foiling the left side. X squared plus 2x minus 8 equals 91, and then you can subtract 91 from both sides. You get x squared plus 2x minus 99 equals 0, and then you can FOIL this, I think. Yeah, 9 and 11. So x plus 11, x minus 9. So you get x equals negative 11, x equals 9.
Okay.
All right, so this is a great place for us to stop. I'm going to send the notes out and the video. It might take 30 minutes. The cloud recording is a little slower right now.
Yeah.
But I'll get that over to you shortly. Thanks for scheduling. I'll see you next time.
Thank you. Bye.
Have a good bite.